Hi, hello, this is still the great teacher, back at it again. And for this video, we're going to talk about factoring general trinomials, but most importantly, we're going to focus on general trinomials in the form of ax squared plus bx plus c, where a is equal to 1 and where b and c are real numbers. So for the next video lesson, we're going to focus on basically where a, b, and c are all real numbers. But in the meantime, let's focus with the task at hand. Task instead of task. Task at hand where a is equal to 1. Let's go at it. So for this part of our discussion, we're going to identify polynomials that we call as general trinomials. In other resources, we also call them as quadratic trinomials. But for the first part, we're going to focus on where a is equal to 1. Later on, we'll have examples wherein there is a value for a other than 1. And we're going to acquire those skills in order for us to solve word problems also. I think that will be for the next video. But before we proceed in factoring what we call as general trinomials, it is important for us to review the following. So the first thing is, it is important for us to recall how to add and multiply integers of same signs and different signs. So Anya is on our top of the screen, always reminding us of our goal in order for us to get that starlight. So basically, class, it's not that difficult. It's important for you to review this skill because this will be something that will help you not just in grade 8, but as you move forward. You're going to have this also in some skills in real life, like integers. It's really important for you to remember how to do this. And I also have those details below the screen. You have the rules when adding integers and when multiplying. So let's start with the first one. So we have 2 and 3. Both of them are positive. So 2 times 3, that's equal to positive 6. I'll just use a better color. I guess I'll use the color white. Will the color white do? Okay, let's see. For the sum, so it's 2 plus 3. That's equal to 5. Next, negative 2 and 3. They are of different signs. So the answer should be negative. So this is negative 6. And if you add these two numbers, again, there's a rule below. Basically, subtract their absolute values, 3 minus 2. That's equal to 1. And since the higher number is positive, it should be positive 1. But if you look at the third example, same numbers, different signs. So 2 times negative 3, it's still negative 6. But now, the higher number is negative. So 2 minus 3, that's equal to negative 1. Or 2 plus negative 3. You can write that also that way, 2 plus negative 3. And it still be 2 minus 3 or equal to negative 1. Same concept. Now, what if we have both negative? Again, if the signs are the same and if you multiply them, the answer should always be positive. And if you add these two numbers, basically add the numbers and copy the sign, so it's negative 5. Next, you have 4 times 5, that is equal to positive 20. 4 plus 5, that is equal to positive 9. So to continue, we also have 7 times negative 8. This will be equal to negative 56. Then if you add these two numbers, it's going to be equal to negative 1. Since negative 8 or 8 is the higher number compared to 7, it's negative, so the sign should be negative. Now we have the same sign here, so the answer should be positive. So this is positive 45. And we have negative 9 plus negative 5. That's equal to negative 14. Next, you have 12 and negative 10. So if you multiply these two numbers, this should be equal to negative 120. But if you add these two, since 12 is higher, so the answer should be positive. So this is positive 2. We also have negative 5 times positive 8. This is equal to negative 40. If you add these two numbers, we will get positive 3. And lastly, you have negative 7 times negative 12. That will be equal to positive 84 since they have the same signs. And in this case also, you're going to have negative 7 plus negative 12. That will give you negative 19. So these are basically really important for you to remember because we're going to apply this thoroughly when dealing with general trinomials, whether it's where a is equal to 1 or where a is also any real number. So it's important for you to remember how to get the product and sum of integers, whether they have the same sign or not. To continue, let us now have different cases or different examples for our general trinomial where a is 1. So as you can see here, our first example, we have x squared plus bx plus c as the pattern. Basically, class here, everything is positive. So it's important for us to identify what is A, B, and C. You don't have to overcomplicate this. And I'm actually doing this also so that you will be trained with this kind of examples. And when you deal with general trinomials or quadratic trinomials by your grade 9, you will remember how to identify the A, the B, and the C. So basically, the A is the numerical coefficient of x squared. In this case, it is 1. For B, it's the numerical coefficient of your middle term or your x term here. So it's 9. And C is basically your constant, which is 20. So now, what you have to do is you have to identify the factors of your letter C, which is 20. Identify its factors, wherein if you add it, it's equal to your middle term. That's our goal. So for you to do that, you may have a table like you're seeing on the screen right now. The purpose of this table is to guide those who are not yet that good with doing this mentally, or for those who wants to be sure with things. And it's okay to have this kind of drawings or tables in your solution class. It doesn't make you a less of a person. Instead, it helps you a lot. So don't be bothered writing more solutions or having more examples on your solution paper. Instead, take it to yourself in order for you to fully learn. Because for some, they can immediately say, oh, the factors here are 4 and 5. That's it. But if you wish to really take it one step at a time, to be sure, you start low. Basically, start with the number 1. So what number do you multiply to 1 to get 20? Well, it's 20. 1 times 20 is 20, and if you add these two numbers, it's 21. So it's not the answer. Next, is 20 divisible by 2? Yes, so 2 and what? 10. So 2 and 10, that is 20 still if you multiply, but if you add, it's 12. So that's not the answer. Is 20 divisible by 3? No. So we don't have any factor for 3 or a pair for 3 to get 20, but we do have for 4. And it's 5. 4 times 5 is 20. And if you add these two numbers, it's equal to your letter B, and that is 9. So these are the numbers that we're going to use. Now, basically from here on out, it's much easier to answer already. You can already identify the factored form of the given general trinomial. So our given is, again, x squared plus 9x plus 20. So the factored form of this one is basically two binomials. First is the factor of your first term, that's x times x. And then we will use the 4 and the 5 that we have received here. So basically, this is x plus 4 and x plus 5. And if you wish to check this, you may apply the FOIL method, because that's the final answer. This is it. So multiply the first terms, you will get x squared. The outer terms, you will get 5x. The inner terms, you will get 4x. And the last terms, you will get 20. So if you combine these, you'll get x squared plus 5x plus 4x plus 20. And basically, this is x squared plus 9x plus 20. So the reason why we did the FOIL method here, or I showed the FOIL method here, is for you to understand that in some references, they use the term that factoring general trinomials is basically undoing FOIL, or it's FOIL method backwards. Okay, so you will see this kind of example later, or in a different lesson similar to this case of general trinomials. It's important for you to understand that for factoring general trinomials, there are tons of possible solutions. In the meantime, I want to focus on identifying factors in some, but for our next lesson, we're going to have different methods in solving one example. Okay? Now, let's go to our next case wherein our middle term is negative. And you don't have to panic here because we focus on the letter C for now. So your A is 1 again. Your B is negative 11. Please do not forget the sign. and your c is the constant, which is 30. So 30 is positive, and we're looking for a pair of factors that will give us a sum that is negative 11. So with that being said, this implies that the factors should still be of the same sign, but no longer positive, but both should be negative. Why? Because negative times negative is positive, and negative plus negative is negative. So let's start again, slow. We can have negative 1 and negative 30. That's positive 30, but if you add it, it's negative 31. So that's not the answer. We can have negative 2 and negative 15. That's positive 30, but if you add it, it's negative 17. We can also have negative 3 and negative 10, but that is equal to negative 13. So we can also have negative 5 and negative 6, and that will give us negative 11. So therefore, these are the two factors that we are going to use. So just like earlier, so you'll have x squared minus 11x plus 30. So the factors are again two binomials. So for x squared, that is x times x. And then you will use negative 5 and negative 6. So basically, the reason why case 1 and case 2 are being shown in two different sides, so left side is case 1, right side is case 2, is for you to understand that we are using factors of the same sign. If everything is positive, the factors should both be positive. If the middle term is negative, therefore the factors that we're going to use are both negative. So I want you to pay attention to that. So this is our final factored form. Now let us proceed to the other two cases wherein the factors that we're going to consider are of different signs. So let's proceed with case 3 and case 4 in this case. Wow, so much cases. So let's identify first the A. Again, it's 1. The B is positive 3. And the C is negative 18. Now again, we're going to identify factors of negative 18, wherein if you add it, it's equal to positive 3. If you recall earlier in our review, well, you will get a negative number as a product if you multiply two numbers of different signs. So for you to get a sum that's equal to a positive number, well, therefore, the higher number should be positive. So let's start with that. So we can have, for example, negative 1 and positive 18. So different signs, the answer is basically negative 18 if you multiply them. But if you add it, it's equal to positive 17. To continue, we can also have negative 2 and positive 9. But if you add it, it's equal to positive 7. We can also have negative 3 and positive 6. But if you add it, it's now 3. So this is what we are going to use. So that's it. So we can have x squared plus 3x minus 18. So the pair of factors, basically, again, we start with the x's, and then you can have negative 3 and plus 6. Again, the reason why 6 is the positive number, because the middle term is positive. Now, if you look on the other side of your screen, on the right side for case 4, both the middle term and the last term are negative. So let's identify the A, B, and C first. So we have 1, negative 9, and negative 22. So C is negative 22, and your B that we're looking for as the sum is negative 9. So basically here, unlike the case 3, the higher number should now be negative. So we can have 1 and negative 22. The answer there, if you add it, it's negative 21. We can also have 2 and negative 11. The answer there is negative 9. So class, here's one important lesson, not just in mathematics, but also in life. Once you find what you're looking for, you can stop there. No need to overthink things. Since we're looking for negative 9 as the sum, we should stop here already. No need to continue. Okay? So in that case, we can now have the answer for this given example, x squared minus 9x minus 22. This will give us x plus 2, and this will also give us x minus 11. And that's it. That is your final answer. And now I think it's also important for you to have more examples. That's why I prepared 10 more different examples. And the beauty of this is that you may practice this on your own. So you may pause this video and then you may try to answer them on your own. Don't overcomplicate this. Again, you can identify the possible factors immediately if you already know them, or you may take it one step at a time as shown in the previous examples, like start with 1 as the factor, and like for example, you can have 72, so that could be 1 and 72, and you can have 2 and 36, but this will take you so long. But once you, or it's okay, but if you already know the answer, you may go straight to that. Okay, but again, if you're still struggling with the factoring, take it one at a time. But if you already get it, go get it already. So for 72, the answer there that we should use is basically we can have 8 and 9. 8 times 9 is 72. If you add it, it's equal to 17. So the factors here are p plus 8 and p plus 9. Now you have number 2. The middle term is negative, but your last term is positive. So they should both be negative. So we can have negative 1 and negative 8. And that's it. So your answer here should be n minus 1 and n minus 8. Now you have your middle term as negative and your last term also is negative. So one should be positive, one should be negative. Since the middle term is negative, the higher number should be negative. So we can have 1 and negative 10. So the answer here is basically x plus 1 and x minus 10. For number 4, everything is positive, so you don't need to overcomplicate it. We can have here 4 and 8 as our answer. 4 times 8 is 32, 4 plus 8 is 12. So the answer here is b plus 4 and b plus 8. Excuse me. Now if you look at this, negative 70 is the last term and the middle term is positive. So basically the higher number should be positive. So we can have negative 7 and positive 10. So the answer here is x minus 7 and x plus 10. To continue, now you have your last term as negative. So you have to be careful with this one again. The higher term should be positive since the middle term is positive x. So we can have 8 as your negative number and 9 as your positive number. If you add these two numbers, the answer is 1. And if you multiply these two numbers, the answer is negative 72. So you get x minus 8 and you get also x plus 9. To continue, you now have the same concept with number 7. So the other number should be higher, and that's positive. So we can have negative 5 and positive 6. So this will be x minus 5 and then x plus 6. Next, you have 40, but the sum should be 13. So that's 5 and 8. So your answer here is x plus 5 and then x plus 8. Next, you also have b squared minus 17b plus 70. So both should be negative. So you can have negative 7 and negative 10. So the answer here should be b minus 7 and b minus 10. And lastly, your factor here is negative. So this should be different signs. The other one is positive, the other one is negative. So you can have negative 3 and positive 6. It's x minus 3 times x plus 6. So that's it. So I hope you got most of them correctly, if not everything correctly. But again, the reason why in this column or in this example I use the term possible factors, it takes a lot of practice to get used to these things. So take them one step at a time. But once you get used to identifying the factors of numbers quickly, adding different signs or same signs, you're going to find these general trinomials where a is 1 easy. It takes practice, so don't be too hard on yourself. Just keep practicing. Okay? So you may refer to more resources online for more practice examples or exercises. But in the meantime, it's all that I can give to you in relation to general trinomials where a is equal to 1. And that ends our video lesson for today. I hope you learned something new, or you were able to recall all the things that you need to recall and master all of the skills that you need to master. As always, remember, in case you don't see me or hear me, good morning, good afternoon, good evening, and good night. Peace out. Respect, everybody.